So in this video, we're still continuing to look at kind of word problems or sentences and then write an expression or equation to match that situation. In the last video that I made, which was about translating either a phrase or sentence into a 1 or 2 step expression or equation, there was a lot going on in that one video. There's the notes page we filled out together that has a lot of the different pieces to look at for the specific wording. So make sure you have that worksheet out so that you can kind of make determinations, on whether or not we're going to be doing addition, subtraction, multiplication, division based on the words being used. Because remember, even in math, in every single subject and all throughout your life, communication is so important. So it's really important to understand what words are being used and why. So that's why we spend a lot of time working on these, just to make sure that we know, what is being told to me in this situation and what does it mean. And the words really do matter. All right. So in this case, we have Martina had $122 to begin with. She just spent C dollars. Sorry. Using C, write an expression for the number of dollars she has left. So let's think and identify. How much did Martina have to start? Well, I see they told me Martina had $122 to begin with. So I know she had $122. How much did she spend? She spent C dollars. So I don't really know exactly how much she spent. It's a placeholder, but it's C. It's some number that we just aren't being told yet. So is spend an addition, subtraction, multiplication, or division word? So spend wasn't one that we put on that chart when we did that before, because it's not as common a word. But if we're looking at real world word problems, spend is going to be one of the ones that they love to throw out there because it's something that's very real world. If I spend money, then I'm taking that money away from what I have. That would be subtraction for sure. So another one they love to throw out in word problems is the idea of giving it away. So, okay, well, if I gave it away, I don't have any more. That's taking it away from what I have. So now we're going to write the expression. So she had $120 and she spent C. And now we need to think, does the order matter? Meaning, can I go C minus 122? Well, we can't do that. The order in this case does really matter. Sorry. There's cats in the background playing, making noise, if you can hear that. All right. So it does really matter the order of how I write this, because 122 minus C is different than C minus 122. This expression on the bottom means I'm starting with some amount and I'm taking $122 away from it. This does not mean I started with 122 and I'm taking C away. So be very careful about how you're writing this, especially when it's a subtraction problem. The order is very specific. Okay? All right. So the next one here, we have a proportional relationship. So a gym has a yoga class. Each class has 13 students. If there are C classes, write an equation to represent the total number of students, S, taking yoga. So in this case, we just need to think about what are we being told. So we know there's yoga classes, and I know there's 13 students in each yoga class. So we're given that there's 13 students in each yoga class. Now let's consider specific cases. So for one class, I would have 13 students, because I know there's 13 students in each class. For 2 classes, I'm not going to have 13 anymore. I'm going to have 13 times 2. So this would be 26, because it's 13 plus 13, or 13 times 2. For 3 classes, I would have 39, because again, it's 13 3 times. I have 13 times 3, because there's 13 in each one of those 3 classes. Or 4, I would have, let's see, we would go with 52. So this would be 13 times 4. So this is just showing us a pattern. And I'm putting this off to the side because this is actually the pattern we want to pay attention to. This was 13 times 1, which is just 13, right? If we notice, the 13 is always there, right? So we can see that part of the pattern. What's changing is the number of classes, right? When I said 1 class, I multiplied by 1. When I said 2 classes, I multiplied by 2. 3, I multiplied by 3. So what's varying, the variable, is our number of classes. That is our variable. That's what's changing. The constant here that's not changing is the number of students in each class. It's always going to be 13. So these examples can help us find the total number of students in C classes, because they asked us to use C for the kind of placeholder there, right? For C classes, the total number of students is, well, if I multiplied by the class number here on these ones, it doesn't change it just because I'm using a variable. I would still do that same thing. This is going to be 13 times whatever the class number is, which is C. So this would just be 13C. So this is the idea of just showing that proportional relationship to show that it's being multiplied. And one of the multiplication words, which I don't think we put this on the chart before, we should have each. That's another very common word used for multiplication. So definitely go and add that to your chart so that you have that kind of word noted down, because it's a very common word used there. All right, so go ahead and give it a try on Alex.